Alright, in this video, we are required to solve these complex numbers R and S. So you are given these two equations. Of course, you are going to embark on the simultaneous situation. Now, it is wise that we need to make one of these variables, R or S, a subject of the formula. Now, it is clear that S is easier because it is just on its own that we can just work with. Now, we can just make S a subject of the formula this way. So we take this portion to the other side. So Ri will remain this way. Then we have minus 5. Then we have I minus 1. So this is our S that can be simplified to be negative 5i, then plus 5. So this is our simplified equation number 3. If this one is equation number 1 and this is equation number 2. Now, ours is to substitute our equation number 3 back to equation number 2. Now, we are going to write r squared minus 2. In the place of s over here, we're going to put what is equal to s. So we have r, then I minus 5, I, let's mix 5 to be 5, so plus 5. Then this is basically equal to 5. Let me just solve that one. So we have 5 times 2i, it's 10i, then minus 5. So we can just go around and simplify, taking away the brackets over there. So that is r squared minus 2, negative 2 times ri, it's negative 2ri. The negative 2 minus negative 5 times minus negative 5 minus 5 is going to positive 10i. Negative 2 times positive 5 is negative 10. So we're done on the left hand side. Then on the right hand side, we can just write them as they are. That means now we can collect the like terms if there are any. Now the like terms is we are having r squared, then we have minus 2ri. Then you can see that this one can just cancel this one because they are like terms and they are additive inverse in this juncture. Then we are going to say we are having minus 10 plus 5, which is just going to be minus 5. It is equal to 0. So we are having this simplified quadratic equation that we can solve the values of r by using quadratic formula. Now in this one, we are going to use quadratic formula. That our a is the coefficient of x squared, which is equal to 1. Our b is the coefficient of r, which means now, let alone that it is not written in a standard form, but whatever that multiplies r is the coefficient of r. That makes it 2i. Then c is the constant, which is now just negative 5. Then r now is going to be equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Doing the substitution now, we have negative in the place of b, we are going to put negative 2i, then plus or minus or square root of, in the place of b we put negative 2i, then we put the square there, then minus 4. Our a is 1, our c is minus 5, all divided by 2 times 1. Then it takes us to negative times negative is going to be 2i. Then we have plus or minus, then or square root of what? Negative 2 squared, it's 4. Then I squared is I squared. Then negative 4 times negative 5 is just positive 20, all divided by 2. Now simplifying this, we are going to have I 2i, then plus or minus 4i squared is basically equal to negative 4. because I squared is just -1. Then we are having square root of 20 minus 4 is now going to be just 16. Then we have that. Then this is equal to 2i divided by 2 is basically just I. Then plus or minus, then square root of 16 is just 4. Then divided by 2, that should make to be just 2. So you'll find that you have two values of r, which is I plus 2, or r is equal to I minus 2. So when you have these ones, now we can just use them towards finding the values of s. Let's remember that s was given by ri. It is ri minus 5i plus 5. ri minus 5i, this is 5, then plus 5. Then for r, which is equal to I plus 2, then our s is going to be, in the place of r, we're going to put I plus 2, then multiplied by I over there, then minus 5i, then plus 5. Then we can simplify this. I times I is basically I squared, then plus 2i, then minus 5i plus 5. Then it is continues to be I squared is just equal to -1. Then 2i minus 5i is just minus 3i. Then you have plus 5. Then you can see that s is equal to -3i plus 4. Then you can see that now for r, which is equal to I minus 2, we're going to find the values of x here. We're going to say, okay, we have I minus 2, then multiplied by I, we're substituting over there, then minus 5i, then plus 5. Then simplifying, I times I is I squared, then minus 2i, then minus 5i plus 5. So I squared is, of course, also -1, sorry. Then -2 minus 5 is minus 7i, then plus 5. So another value of s now is going to be -7i, then plus 4. So these are the values that they wanted, s, and these are the values of r that they wanted. We have solved them using simultaneous approach. Now let's say you have this information. They say prove that s is equal to 2i and r is equal to 1 plus I. So here you are working on something that is given, so you will know when you went wrong. Yeah, it's a bit complicated, this one, because it is not easy to run away from the fractions. But anyway, we are going to pull through because we have to do it. So how does it go? I think we can just force this r to be the subject of the formula, because this is one way of doing it. One variable must be the subject of the formula. Now by doing that, we are going to take this I to the other side. Now we are going to be left with 5r, which is equal to 7. Then plus, we can just expand this one shortly, which is going to be 3s, then plus si, then minus I. Remember, we've taken this I to the other side. So we have 5. For now, we haven't done because r is still not the subject of the formula. So we can just divide by 5 both sides. So r is equal to now 7 plus 3s plus what? Plus si, then minus I, divided by 5. So this is our simplified equation number 3 if this one is given by number 1 and this one is given by equation number 2. So ours is to use this equation number 3 towards equation number 2 so that we can solve the remaining variable. Now in the place of r there, let's just put this one first. We have 2 minus I times r plus 2is, then plus 1 is equal to I. Then there's a little bit of algebra that is going to play around here. Let's just try not to make any mistakes, because the mistake that we make is going to cost us to get wrong answers. Remember, the answers are given there is 2i and 1 plus I. So if we don't get these ones, we must know that somewhere, somehow, we have made a mistake. Now, having this one, we can see that, all right, this is r. Remember, we're just dropping this one down. So in the place of r, we're going to put what is equal to I, which means that it's what is found on equation number 3. So what we have 2 minus I. Then in the place of r over here, we're going to put this stuff. Okay, now what are we having? We have 7 plus 3s plus si minus I, all divided by 7. No, not 7, but 5. Then we have simplified it parallel. Then plus this plus, we're going to put it here, plus 2is plus 1, then is equal to I. So it's all there. But anyway, we can just take this I to the other side so that we can have simplified something equal to 0 there. Now, since we are not happy with the fractions that we are turning into, we can just multiply by 5. We multiply all these terms by 5, basically, so that we can get rid of the denominator over there, because we are solving anyway. So when you multiply by 5, this 5 is going to cancel that one, and this 5 you multiply by it over here as well, then it's going to be simplified that way. So let's get it wrong. Then when we multiply, we are going to be having 2 minus I, then we have 7 plus 3s, then plus si minus I, then plus, remember these terms are multiplied by 5, all of them. So you'll be having what now? 10is, then plus 5, then minus 5i is equal to 0. So let's just be careful. My 5 usually be the same as s, but that is why I'm trying by all means to make them look different. Now we can just expand this binomial times polynomial. So we have 2 times 7, that is 14. 2 times 3s, that is going to be plus 6s. Then 2 times si, that is going to be plus 2si. Then 2 times negative I, that is negative 2i. So we are done multiplying by 2. Let's multiply by I now throughout. So we have negative 7i. Then we have negative 3si. Then we have negative si squared. Then we have positive I squared. So we are done with I as well. So then plus 10is, then plus 5, then minus 5i is equal to 0. So we have that now. And let's now do the simplification by collecting the like terms, if there are any, and identifying those numbers that are real. So we have 14. Then this one is just a real number, because square root of I squared is just negative 1. So we just have negative 1. Then we also have this one, which is 5. Then we say plus 5. Then I think we are done with numbers. Let's get into s. For example, we have 6s here. Then we also have this one, because negative s times negative 1 is just positive s. So we are having 6s plus s, which is just going to be 7s. So let's just say we are done with this one and this one. We also dropped this one just now, and we also did put negative 1 there. Then this one is also returned. So what are we left with? We're left to do this one and which one, and this one. So we are having 10 minus 3, that's 7. 7 plus 2, that's going to be 9. So we have plus 9 SI. So let's get, which means we are done with this one and this one and also that one. So we are left with I's. So this one and what? And this one, they just, okay, also this one. So we have 9 minus 5. That's going to be basically 14. So we have 9. We have what? We have 7. This is just 14, right? So we have minus 14 I over there. This is equal to 0. Okay, so we have this. Now what are we having? We are having something like these ones can be solved, which is 14 plus 5, that's 19 minus 1, that's 18. Then 7s and that one, it's basically, yeah, we have 7si and that, so plus 7s. Then this one we can just say, yeah, let's just have plus 9 si for now, minus 14i. Let's just remember what we are looking for. We're looking for s because that's the variable that we are respecting. So let's just take everything else that is not for s there away. So which means now we can just take s 7 plus 9i, as we have factorized this portion. So the rest must move to the other side. So we are going to be having 14i, then minus 18 over there. So we are now going to be dividing by this because we are not looking for it. So we have s is equal to 14i, then minus 18, then divided by 7. Let me just start with 9i, then plus 7, right? So we have this one, and our s is not that solutions that is given there. I think we have to do something so that the real part and the imaginary part stays on their own. Now let's get into how do we simplify this one. You'll remember that when you're dealing with rationals, we have to multiply by the conjugate of the denominator, right? So the conjugate of the denominator is going to be 7 minus 9i divided by 7 minus 9i. So it might be confusing when it is put this way. The idea is that the conjugate, you just change the sign of the imaginary part. So if this one is positive, now you are going to be negative. So that is why I have just also managed to swap them around so that it can be clear enough that this is what we have. Now, what do? We do the simplification. Then 14i times 7, which is 14 times 7 is equal to 98. So we have 98i. So then 14 times 9, this is basically going to be negative 126i squared. Okay, then we are done with that one. Then 18. So 18 times 7. 18 times 7 is going to be, since we have negative, so it could be negative 126, right? So we also have 18 times 9. That is going to give us what? Positive. That is positive 162i, right? So this is basically what we have. So divided by the denominator usually becomes the sum of two squares. So 7 times 7 is 49, then 9 times 9 is 81. So we're just going to be positive 81, then plus 81. So this is what we have. So in the numerator, you can simplify because this one and this one, they seems to be the same. So 162 plus 98 is just going to be 260i. Then what are we having? We have this portion and this portion, and you can see that this one negative 126 times negative 1 is just basically positive 126. So these ones are additive in phase, surely. Then they are going to do what? They're going to cancel each other. Now what are we having? After that, we just have that in the numerator. Then in the denominator we have 49 plus 81. So 49 plus 81 is just 130. So we have 130 qha kuphela. Then this is equal to, so what are we having? 260 divided by 130 is basically just 2. So we have this 2i kengoku. So this is the value of s. This is the value of s that we were solving, that we were proving. And sorry for this one, let me just take it off just here by mistake. Sorry for that. Then let's go for finding if the value of I just a little bit. Let me just change this portion, this template, so that it becomes something that, okay, we are here now, changing the template so that, yeah. So if we can continue now finding the value of r, so r is equal to, you will remember that our r was equal to this long thing. So let me just take it down. Then this is our r over here. This is our r over here. Then let me just put it here. Yeah, so this is our r over here. So if s is 2i, so in the place of s we're going to put that. So we have 2r is equal to 7, then plus 3. In the place of s we can put 2i, then plus 2i times what? Times I, then minus I, all divided by 5. Okay, so we can continue to say, okay, we have 7, then plus 3 times 2 is 6i. Then we have plus 2 times I squared, then minus I, all divided by 5. So simplifying this, so this one becomes 7 minus 2 is 5. Then 6 minus 1 is 5. Then we have plus 5 I, all divided by 5. So 5 divided by 5 is just 1. Then plus 5 divided by 5 is just that. So this is the value of r over there. So we said r must be equal to 1 plus I, then s becomes 2i. Let's just confirm if really this is what was given. So this is what we have. So we managed to pull through all this stuff. I think this is an amazing why. Then I will bring along another good stuff for complex numbers. There is a lot. So see you in the next video. Bye.